Originally, we started just up the road from Milton Park as a private company embedded within a government research lab. But we realised we wanted to move very quickly, hence relocating to Milton Park about 2013, and then go through a series of buildings as we scaled up our activities. We have our operating Tokamak. We've been able to modify that device, add to it over time. In addition, we've been developing high-temperature superconducting magnets, which are very special in their own right and can enable all sorts of new innovations in future.
Fusion is the process that powers the sun and other stars. Fission is taking a big atomic nucleus and breaking it apart into smaller particles to release some energy. Fusion is the opposite. You fuse them together, and that also releases energy. Tokamak Energy, we use a Tokamak, which is a reactor that's kind of shaped a bit like a cord apple, and our plasma kind of travels round and round and round inside this vacuum chamber.
The plasma we run is a deuterium plasma, and we have two heating ion beams that heats up the plasma. We run neutron diagnostics. We look at the plasma density, plasma temperature. We look at the different ion and electron temperatures. And in total, we have around 40 different diagnostics that are looking at different plasma parameters.
In ST40, we achieved the highest temperatures basically in the solar system at that point. So we measured a temperature of over 100 million degrees in our plasma, which is about 6 or 7 times hotter than the center of the sun. Yeah, I got to work on the systems that measured those temperatures hottest in the solar system.
There's lots of magnets in fusion. The more powerful the magnets are, the more you can confine your plasma, and then the smaller you can make your tokamak. We also use the magnets to control the plasma, so we have our colloidal field coils, which are the top and bottom, they can shape our plasma. And then we also have magnets which drive the current around as well. So there are lots of fusion businesses around the world. Many of them require magnets. We are the experts in high temperature superconducting magnets, so we would like to help them realise their vision for fusion. And if they're using our magnets and our magnet technology, then we win as well.
One of the reasons we can succeed is the location. As the team gets larger, it gets more important to be in a place that's well located, where people can travel in relatively easily. And then people expect more and more amenities on the park, and Milton Park's been really good in that respect.
So I quite personally like the fact that Milton Park is just a nice place to work. There's an awful lot of sort of grassy areas. They have all the little bee houses scattered around the park. So it's great to be able to go out at lunchtime and go and enjoy the park.
I really appreciate the bus pass scheme. Net zero is important to me, and being able to bike and have the cycle paths on the way to work, but also the bus pass scheme is really nice for those days when it's absolutely tipping it down.
The future, I think in the next 10 years we're going to see continued government enthusiasm for fusion. The scene is set for us a strong 10 years, culminating, we hope, in a fusion pilot plant.